Hi folks, Mr. Long here. I'm going to do a screencast today for what are called Riemann sums. That's area under the curve. And to begin with, we're going to learn about what left Riemann sums are. So what are we trying to accomplish with these? Well, I think we probably know enough about what that means now. So that right there means getting the area under some curve f at x, okay, from x equals 0 to x equals 6. That's what we're trying to do. Now, what we're going to do is we're going to estimate that area under the curve with rectangles, okay, with different rectangles. And what this is going to do, this video will do, is teach you the process for that, okay? So there's some things like the questions, if you notice, the question says estimate the area from 0 to 6 for f at x dx, right? And then what's going to happen is it says we want to use 3 subintervals using a left-hand LH sum. Well, subintervals just means the number of rectangles. Intervals or subintervals gets used for the number of rectangles. So what does this mean? Well, we let n be the number of rectangles. The total width is b minus a, where it's the integral from a to b, f at x dx. So in our case, then the total width, and then delta x is the width of each triangle. Did I say triangle? Rectangle. Okay, so there we go. So those are the things that we need to think about. So in our case, we know n is number of subintervals or number of rectangles. That's 3. We know that a to b is 0 to 6. So b minus a equals 6 minus 0, which is 6. Delta x equals b minus a divided by n. So a total width of 6. And we need 3 rectangles to cover that. How wide is each rectangle? Well, whoops, it's going to be 2 wide. Okay, 2 wide. So each rectangle is 2 wide. I would always focus on a sideways table of values. Make yourself a sideways table of values, even if they give you a vertical one. Usually on an AP exam, though, they're going to give you a sideways table like this. And what we want to always remember is delta x is 2. That means each rectangle has a width of 2. So if each rectangle has a width of 2 and I'm going all the way out to 6, well, and I'm starting at 0, that means the first one is going to go to 0 to 2. The next one is going to go 2 to 4. And the third rectangle will be 4 to 6 because they're each 2 wide, okay? And we do that with x, okay? We do that with x. And then there's this whole idea that it's a left-handed sum. What does left-handed mean? Left-handed means I get the y value on the left side of the interval. Okay, the left-hand side of the interval. So what I'll do here is I'll just maybe put each. You know what? No, I'm not going to do that. I think it's better to see it just the way we had it before. Okay, so the first box, or first rectangle, goes from 0 to 2. What I'm going to do now is I'm going to circle the left-hand side of that box. Okay, what's the left-hand side of the second box? Well, the left-hand side is 2, and the y value at x equals 2 is 4. What's the third box? The third box goes from 4 to 6. What's the left-hand side of that? 4 and 16. By the way, f at x equals x squared, right? You can kind of tell just by looking at the pattern. 1, 4, 9, 16, 25, 36. So now how do we go about getting the area? Well, actually before that, let's actually draw our rectangles. Okay, so I'm going to draw our rectangles. So remember that it's a left-hand rule. So I'm going to go, the first one goes from 0 to 2, the second one goes from 2 to 4, the last one goes from 4 to 6. But I'm going to get the y value at the left side. So the left side of 0 to 2 is 0. The left side of 2 to 4 is at x equals 2. The left side at 4 to 6 is right there. Okay, so that's going to represent where the rectangles go. And if the rectangles are going to go across and actually to the right, okay, because the y value is on the left side of the interval. That's going to make this first rectangle have an area of 0 because the y value at x equals 0 is 0. Okay, so A1 would be the area of the first rectangle, A2 is the area of the second rectangle, and A3 is the area of the third rectangle. All right, so let's go back to our table down here. And remember that the area of a rectangle is just base times height, right? That's a nice simple formula there. Area is base times height. And the base for each of these is delta x, right? So if you think about this, the rectangle area is actually the base, which is delta x, and the height, which is f at x, the y value. Okay? Delta x times f at x. That's the area of the rectangle. So look at the first one. It's on the left side. So delta x for all of them, right? The width is going to be 2 for all of them. So I'm going to put a 2, a 2, and a 2. And this represents the first rectangle, second rectangle, and the third rectangle. Then, so that's delta x, right? Then it has to multiply by the y value on the left side. Well, what's the y value on the left side of the first one? It's 0. Okay. What's the y value on the second rectangle? It goes from x equals 2 to x equals 4. Well, at x equals 2, y equals 4. And on the third rectangle, now, which goes from x equals 4 to x equals 6, that's going to be, the width is 2, and then again, in this case, the height is 16. Okay, the height is 16. So again, what is it? It's delta x times by f at x. Delta x times by f at x. Delta x times by f at x. How do we get f at x? It depends whether we do it on the left side, the right side, the middle, or something called the trapezoidal rule. Okay, and then you would just multiply that out, simplify, and you would have an estimate for area under the curve. What I want you to notice, though, when you do a left-sided rule, so if I'm going to shade in some things here in red, what do you notice about that, that, and that? This function is increasing. Okay, it's increasing. So if this function is increasing, what happened with respect to the rectangles? So is that total area that I got there? Is that, and I want you to figure out the total area, by the way. Is that total area, is that an overestimate or an underestimate, right? Did I have extra area left over or not enough area in A1, A2, and A3? So I'll let you think through that as well. Okay, good work. Let's move.